Hello there, welcome to another exciting session with us. I am Victor. Today we'll be talking about what young engineers need to know as they go into the field of engineering. And we'll be talking to an expert who holds 38 years of experience working with the National Aeronautical and Space Administration in the United States of America. His name is George Salazar. George Salazar is an expert in communications, data handling, telemetry, and voice recognition, and holds so many patents in engineering. He has mentored over 16,000 students, so we are very much opportune to have him talk to us, to have him speak to us and learn some very crucial things from him. In this session, he answered 5 very important questions that pertains to engineering, told us about his experience and what we should know, what we should learn that are not taught in colleges that will make us high-performing engineer. So I endeavor you to sit back, get your pen and your paper, write down some stuff, what you don't understand or what you think you can contribute, write it down in the comment section. And I want you also to invite other people to watch this video. It's a life-changing experience. This is just one in many sessions. We'll be having experts talk to us from Google, from Facebook, from Tesla, from Microsoft. So I endeavor you to subscribe to this channel. Turn on the notification icon, because when next I upload the video, you should be the first to watch it, to have the first-hand experience of what the expert is saying in the field, so that you become a high-performing engineer. So sit back, relax, and watch this next session. Sit in mind to teach STEM, to educate STEM remotely and get other persons involved in STEM, because I think, or I know that since I started engineering, it has changed my life positively. It's something that is a game changer, and I've closely followed you, gone through some of your articles online, researched widely on you, read some of your articles, read some of your work, and I'm deeply inspired, sir. I'm so inspired. I have done a detailed research on some of your work, and in telecommunications, I can say, I very well can say you're an authority in telecommunications. So, and I want to go into telecommunications. Talking to you again is, yeah, I think I've made it in life.
Well, I'm glad, and thanks for the kind words. I have to say that my life has been kind of like there's a song written many years ago by a former Beatle by the name of John Lennon. And let's see, the song I think was called Beautiful Boy. And in it, there's a line that says, life is what happens to you while you're busy making other plans. And so that's kind of what happened to me. Growing up where I grew up in kind of like the ghetto of Corpus, I never would have thought I'd end up at NASA, to be honest with you. And, I struggled in school a little bit. And so, but it just takes a little dedication, a little hard work, and a person will get there.
Yeah, I'm motivated. So quickly, I wrote down some questions here that I want to ask you. So you give me reactions, and others can learn from watching the videos also. So the first question I have here is, how has your journey been thus far with NASA? How's your journey been? Because I think recently I saw on your LinkedIn profile that you've been with NASA for 35 years.
I'm sorry, can you repeat that question, please?
Okay. From your LinkedIn profile, there was a pop-up notification that came up that you've been with NASA for 35 years.
A little over that, yeah.
Okay. And my question is, how has it been thus far? How has it been for you? How exciting has it been? What has been the journey thus far?
Yeah, it's been a fun journey. When I first started coming out of the university, I began to realize very quickly that I knew very little when I started working there. And so I was very fortunate to have mentors, to kind of help me, and I had very good supervisors that helped me learn very quickly. And a couple of things that I learned from some of the former Apollo engineers that I work with is that you're not going to know everything when you you get out of school, and learning who to ask and where to look for information is important, and that's what I did. I I start to learn very quickly. Okay, who are the experts in this area, and where can I find information on this? And that helped accelerate me because the first project I had on the space shuttle program, I there was areas that I had no clue about, and so I had to learn very quickly in order to make the flight experiment successful. So and I have to say that a lot of projects, it was an evolution for me. I started to evolve in terms of learning more and more. In fact, that's why, if you see in my profile, I got a master's in systems engineering. I
Yeah.
started to learn very, I started to learn very quickly that I was working at a system level. I was working the big picture, if you will, not just the little electronic box here, but how this electronic box connects to the other system, and how that other system connects to other systems, and how they interact all together. And that's part of systems engineering, sometimes, and then systems thinking. But the systems engineering part started to become very obvious to me because when we start developing systems, uh, you have to think about, first of all, designing for the application design, but you also have to think about designing for safety. You got to design for reliability. Then you got to test all this, and how you're going to test it. So you have to plan testing. There's a lot of planning going on. There's a lot of upfront thinking. So it broadens your perspective about how to plan things out. And I tell students that. In some respects, systems engineering is kind of like the scientific method, um, which scientists use. And so systems engineering is what engineers use, but the scientific method is always, make observations, form a hypothesis, design an experiment, do the experiment, gather the data, compare it against your hypothesis, and see if it's aligned correctly or not. And the same thing with systems engineering, and that's over the years is something that I did quite a bit about. And so when it was time to think about going back for an advanced degree, I said systems engineering was the degree to go for, and it was the right move for me. In terms of other projects over the years, again evolution. I took on more responsibility. I started to learn more about that, and now I'm in an area that actually I'm still learning. I've recently became involved with what they call human systems integration, which basically is considering the human element as part of the system. When I was going to school, especially electronics engineering, they taught you how to design the best hardware, the best software, but they never talked about the human using the system. And so
Sure.
uh, this is something that I'm now learning about the human element, the capabilities and limitations of a human, and that's one of the reasons why there are accidents. That's why there are airplanes crash. That's why ships run into other ships because they fail to understand how to use the system, or the system was not very user friendly. Um, there was a major explosion in India many years ago, and they found out that there was a lot of human things that basically the human did not understand, and so there were let's call it miscommands to the system. So the human element has become important, and that's the evolution I've kind of taken right now,
Wow.
is not just the hardware and software, but also understanding the human element as well.
Wow. Um, I've written so many things in my diary, like if you write quotes, you have to know where to ask and look for information. Very important. Thank you very much for that, sir. I'm inspired.
Sure.
I'll be going for my master's degree very soon. So these are some of the the tidbits I'll be putting in together to apply for a particular program. Thank you very much, sir. Yeah. So the next
Sure.
question is, okay, what are some of the challenges you faced at the beginning as an engineer right from college? What are some of the challenges you faced?
Say that again, please.
Okay, as a fresh graduate, when you left the college, when you left the university, what were the challenges? What were some of the challenges you faced trying to get into the field of engineering proper?
Oh, when I graduated from college.
Yeah.
Okay,
Well,
so
some of the challenges you faced before you got into the system, before you got into NASA, before you started practicing engineering.
as a young engineer.
Yeah.
Well, I mean, it was actually a couple of challenges. First of all, was it became obvious to me that what I was taught in school was just scratch the surface of what I needed to know, to do my work at NASA. And so I had to, basically learn quite a bit about circuit design, how NASA designs systems. And the other part, to me, this is actually the more important part, is learning how to work with people, people skills. Okay, something again not taught in engineering. They teach you to design and do analysis and all this, but if you're going to be working in a company, you're going to be working in a team, and understanding human dynamics becomes very important. That's something I didn't know anything about, and so I was starting to see in some projects that it was a little challenging working with a person that was very hard-headed, working with people that basically were not reliable in some respects. And so I had to start learning about how to deal with people and how to work with people. So, the whole aspect of negotiating, the teaming, how to work together as a team, understanding different personalities. Everybody's different. And so everybody brings to the table different skills and different capabilities and abilities, and it's learning how to leverage those skills and working with those people. So when I became a project manager, there were a couple of engineers that were very smart, highly intelligent, but very hard to get along with. And so you just can't say, well, I don't want you in my project because I don't like you. You can't do that. So you have to learn how to work with those kind of people, and the whole aspect of people skills that I tell students now that that it's not just technical skills, but also soft skills. And so what I try to share with students when I work with students at universities on projects is I try to share a little bit about that aspect of it, so that way they get to let's say sharpen their skills in that area, and they put that on their resume, because a lot of companies look for engineers that not just know the technical, but also can be working in a team, because every project is going to take more than one person, to make it happen. And so you have to know how to work as a team. You have to know how to communicate with people, both verbally and written, negotiating. What's the other one? Making decisions. Okay, you have to make decisions. You cannot be what we call it in the United States wishy-washy, where I'm not sure which way to go.
No, so indecisive and stuff.
You have to be very decisive. Okay, very decisive. And I learned that very quickly in my first flight experiment, because there were decisions that had to be made at a certain time, and so I had to learn to be more methodical in making a decision in order to keep going, making the project keep going forward. So and more so when we flew the experiment, I was sitting in the mission control room, And so they were doing the experiment, and there were some issues that came up, and so the payload manager that was kind of like overseeing all of the experiments on shuttle, he said, "Well, what are the astronauts need to do?" And the first time he told me that, I kind of froze. I I couldn't decide. And he said, "You're gonna have." He told me, "Hey George, if you want to, if you want this experiment to be successful, you're gonna have to decide quickly and decide what you want, and so I can send that information to the astronauts." So I started to learn you had to be very decisive very quickly, uh, and that's something that sometimes it's not taught in school. You're learning about designing, learning about whatever area you're majoring in, but all these other things become equally or even more important. You could be a perfect straight A student, perfect engineering student, uh, skills. Your project could fail. You could have a failed project not because of the technical, but because of the human element, if you will, the human interaction, the human capabilities, skills that are important in a project. So it's something that I have to say in my early years that was a challenge, is to learn that by the seat of my pants, as they call it. But I also started taking classes and trying to find out what classes I had to take in order to become a better decision maker, in order to be a better communicator, in order to be this is the one that was very challenging for me, in order to be a better uh, written communicator. Writing was not my strong skill,
Wow.
and I took classes in writing English, and then I learned that the English writing that I took in college was not the same as technical writing that you do in engineering. Engineering technical writing has to be short, concise, to the point. And so I was lucky that my supervisor was very patient with me when I was writing my reports and telling me, you need to write this more clear. You need to do this, be more concise here. And so I started to learn about the importance of technical writing as well. And uh, I think that's been beneficial because now I have I've been able to write technical papers that are a little bit more understandable than they were when I first started doing this.
Wow. This, I've written, my diary is full. I've learned a lot from this. Thank you very much, sir. So I'll go to the next question is, what do you think? Okay, the question here is, what do you think young engineers are getting wrong from your own perspective?
Okay,
What do you think?
something's happened.
Next question is, what do you think young engineers are getting wrong from your own perspective? Over the years, you've mentored students, you've interacted with young engineers, prospective engineers from different fields. You've worked with them in your industry, you've worked with them in NASA, you worked with them in projects. What do you think they are getting wrong, foundationally wrong, coming into the engineering field?
Okay,
Yeah, what are they getting wrong coming into the engineering field, owing to your years of experience?
okay. What do engineers get wrong from my
Yeah.
years of experience? The young engineers.
Yes, yes.
Okay. Well, I mean, I have to say that, oh boy, there's some different pieces that the young engineers get wrong. Um, so one that I think, okay, so the ones the engineers in school that are very that make good grades and all that. One of the things that I have found is that there are some young engineers that are very, very smart, and they have an ego. They have an ego problem.
Mm.
In other words, they say, I can solve this problem myself. I know how to do it. But then they find out that they can't. And they keep thinking that they can solve the problem without help. Okay. Again, it's because they, hey, I was a straight A student. I should be able to solve this problem. And I can tell you that most problems, especially at NASA, they're not book problems like you learn in school, where you can, solve, you're assigned book problems and the answers are in the back of the book, or the professor gives you an answer. It's not like that. You have to, you're given a problem, and you need to figure out how to solve the problem, and it takes more than one person. And so the ego part is something that some young engineers need to get over. In other words, they need to understand, hey, I'm not as smart as I thought I was,
Mm.
and so I need to ask for help. Um, and even seasoned engineers. Let me just share a quick story with you on
Okay.
space shuttle. I was working on a program, and we had a particular major aerospace company working on a particular um, design for the space shuttle. And this person that was assigned the design of this particular circuit had a very successful record designing for the military systems. Okay, and so uh, he thought he could solve the problem, uh, but the supervisor of this engineer had a lot of faith in him because of all the successful work that he had done over the years. And but the problem was, this was a more challenging problem that he had ever encountered. And so he kind of kept to himself that he was having problems. And he never said, hey, I need help here. He never said that until it was too late. So when we came to a design review, he basically said, I'm having trouble. And, a lot of us said, why did you wait so long to tell us this? And so anyway, it ended up costing us, ended up costing them almost $2 million and about
Oh.
6 months delay in the design and in the delivery of the product. So this was a classic. So there were two things that were going on. One was the supervisor basically had a lot of faith in this person because of his record, right? And
Mm.
so when the person would say, when he would say, everything going okay, and he would go, yeah, everything's going okay. So he had faith in him, and but he never questioned. Okay, tell me what you're doing, and he never asked that. We call it complacency. You're very complacent. In other words, you assume that what you're told is correct. Okay, and sometimes that happens because of credibility and all that. So that part. Um, so apparently this person never had this kind of issue before, and he was always accustomed to success. And you can never uh, you can never assume that you'll always be successful. Every problem that you take, even if you were successful before, you have to say, uh, I have to be honest with myself. If I'm having trouble, I'm going to find out what the problem is, or I'm going to ask for help, and not say, oh no, I'm very smart and I know I can solve it. I know I can solve it because I'm very smart. You just have to be humble, if you will, and know when to say help, help.
Yeah.
I'm having issues. So that part of it is obviously something that young engineers need to be aware of. And then again, understanding that everybody's different, different personalities, and so that's the other key thing. Again, it goes back to working in a team. There's this. I belong. I belonged for many years to a organization called Toastmasters International, and I joined that because Toastmasters International is a organization basically dedicated to help you become a better speaker, and that's something that I was never good at, still struggle with it, but there's a saying in Toastmasters that says that um, the worst mistake you can make in a conversation with somebody else is to assume that that person thinks like you.
Mm.
If you make that assumption, you've already made a big mistake. You know, think about, let's say, and these are kind of worst cases, like in religion or politics, right? If you start talking religion or politics, well, if you think that that person assumes politics or that he or she thinks politics like you do, you might have made a big mistake there because maybe that person does not think like you. So it's the same thing in engineering. You can't make the assumption that the person thinks like you do. So, and that's why we have teams when we're designing, that we have ideas come in from different people, and everybody is heard. And that's important too. That's part of teaming. That's part of working with a group, is to have this what we call receptive to information from everybody, and don't have this idea that says, "Oh, that's a dumb idea." You know, you don't do that. Every idea is important, and because one idea could lead to something else, and I've seen that many times. So, again, unfortunately, not taught in school, or and if it is, you know, the student is very lucky. But I can tell you that for the most part, you have to learn a lot of this. What's the word? Undocumented information, not in books. You know, I mean, there is some books there, but not in engineering books. You open up a book on circuit analysis or a book on thermodynamics, you know, you're not going to find anything about, you know, working in a team and all that.
Yeah.
You know, they're going to talk about, heat transfer equations, circuit design, equations, and all that kind of stuff. It doesn't talk about humans, and yet humans are part of the process.
Well, thank you so very much for that. I've just been listening, writing down information, learning, and I've learned quite a lot already. Thank you very much for that. Then the very last question.
Okay, tools in terms of aids to help them in school.
Aids, resources, information, personal skills, organizational skills, anything. What do you think they need from your own perspective?
To be successful in STEM fields?
Yeah.
Well, you know, to be successful in the STEM field, you know, and so everybody's a different learner. Everybody's different in how they learn. I can tell you that in engineering, most people like myself are people that learn by doing. And unfortunately, you know, the engineers, you have to, you know, you have to learn. Actually, unfortunately, is to take tests, right? You have to learn how to take tests, and you know, I can tell you from my personal experience, you know, sometimes grades don't really measure a person's ability. I was not a very high GPA student at the university, but yet I was able to accomplish quite a bit. And so, but the tools, you know, you need is obviously do the best you can, and don't compare yourself with others. In terms of, you know, this very well in taking, but they don't do very well in solving problems, real world problems. I've seen that. I've seen that. So, you know, but you know, the main, you know, the tools to me is your main tool is obviously your brain. um, and that's and seeking as much knowledge as you can. Obviously, when you're going to school, you're going to have to pass the courses, and so you do your best to to pass the class and make a good grade and all that kind of stuff. But also, don't take the opportunity to learn beyond that. To learn beyond that. Thing that I have to say, very much dependent on the professor, is to ask a lot of questions about how does this apply in the real world. Okay, professors, I had some professors, that they would just fill up uh, chalkboards, or I don't know, they call them whiteboards now, but back when I was going to school, they used to be chalkboards, and they would fill up the chalkboards full of equations and all kinds of stuff, and they have like equation after equation after equation, and and here you are as a student, trying to write down notes and but that was not, I think back and I said, well, wait a minute, we need to step back and look at what this professor is writing and say, hey, how does this apply to a real problem? Let's do an example here of how this is going to be applied in the real world. I can tell you, we went through a lot.
Thermodynamics, and the equations were very simple, easy to
understand. They meant something.
Wow, thank you so very much, sir. My head is filled with so much information. I have to go back and watch this video to absorb more. Yeah, so thank you very much. Well, guys, yeah, thank you very much for staying to this time. Yeah, you are the VIP here. You learned a lot indeed. Yes, please subscribe, like, and share this video. This is the only way you can support me. The next session will be mind-blowing. We'll be talking to different experts. This is the channel for you to hear from the experts. I'll be talking to you. They will be talking to you. We'll be learning together. That is the essence of STEM education. Thank you very much. See you in the next session.